Good morning. I'm Darrell Brugink, Executive Editor with No-Till Farmer, and I'd like to welcome you to today's webinar where we're going to learn about strategies to improve plant germination in stands and no-till systems. We'll look into some of the seed germination and seedling emergence issues that you're likely to come up against and then some possible solutions. Today's No-Till Farmer webinar is sponsored by Agro-Culture Liquid Fertilizers, and here to help us learn more about taking steps toward improved germination in plant stands in no-till is Reid Abbott, and he's the Field Agronomy Manager for Agro-Culture Liquid Fertilizers. We look forward to hearing from Reid in just a moment. But before we turn things over to Reid, just a couple of items we want to make you aware of. On your screen, you're going to see a box. Within that box is another smaller orange box with a white arrow inside of it. You can click on that. It's going to open up a question field and allow you to submit questions at any time during the presentation. And at the end of Reid's presentation, we're going to look to answer as many questions as possible. If for any reason the webinar is disrupted or you're seemingly disconnected from it, just go back to that invitation email you received and rejoin the webinar through the web link in the email. So with that said, I want to thank you again for joining us, and we're going to turn over the controls to Reid Abbott. Good morning to you, Reid. Thanks for leading today's webinar. How are you?
I'm doing fine, Darrell, and yourself?
I'm doing great. Thank you.
Very good, very good. Well, I appreciate the introduction there, and just to start things off, to give you guys a few of my qualifications, as Darrell said, I'm the Field Agronomy Manager for Agro-Culture Liquid Fertilizers. I graduated from Texas A&M University back in 2005 with an agronomy degree. Shortly thereafter, I moved to Oklahoma, and specifically the Oklahoma Panhandle. I was a crop consultant out there for about 5 years. I was hired on with Agro-Culture Liquid as a salesman after that, and moved back to College Station, Texas, where I reside now, and then last spring made that transition over to the Field Agronomy Manager. So anyways, I've had quite a bit of an experience in no-till farming systems, as well as reduced tillage farming systems up there in the Texas Panhandle, and so I'm proud to join you guys today and hopefully teach you a little bit about maximizing that early season germination and emergence issues in no-till systems. So with that, I'll go ahead and get started. If you had the promotional or read the promotional, I'm just going to go through here what we're going to cover, some of those bullet points. I'm going to hopefully get us to understand how uniform timing of emergence and uniform final stands are key to optimal yields. We're going to cover other management advantages of those even emergence and uniform stands that are associated with that. We're going to look at some of the causes of seed germination issues and emergence issues in no-till systems, and then finally hopefully get you to get some solutions out of that and how to manage that no-till farming system to achieve that effective emergence out of your crops. So with that, we'll get started. The first thing I want to make sure that we understand is that yield loss is pretty rapid and unrecoverable from day one with these uneven stands. Corn plants that are delayed as little as 7 days often produce those runt ears that you see out in the field. I'm sure as you've walked some fields in the past, you've probably seen those plants, wondered what happened. A lot of that is due to delayed emergence. The plants that neighbor those those delayed plants don't often make up for the extra yield, even though they're robbing those plants of the extra light and nutrients. So there's really not a whole lot we can do to recover that lost yield in those delayed plants. And the other thing I want to highlight, I guess, is the recent trend that we're seeing towards fixed ear varieties versus the old flexed ear varieties. A lot of these new fixed-eared varieties have the capability of great yields, but they also seem to fall hard and fast if any one little thing goes wrong with the season, and that can be as easy as having a delayed emerging stand or something like that, drought or what have you. So used to those fixed-eared varieties had the capability of maybe making up for that a little bit better than these fixed-eared varieties that we have today. So again, keep that in mind when you're looking at your no-till fields this year. This is a graph. I believe I pulled this off of the Iowa State Extension website. This was a trial that was done where they actually hand planted this cornfield, and you can see that there's two different populations here. They have a 36,000 plants per acre and a 44,000 plants per acre. The left bar there represents a uniform stand, or the stand where they planted all the seeds in the same day. The next bar over, they held back 25% of those seeds and planted them once the crop began to emerge. And then the far right bar is where they held back that 25% and waited until that plant or the crop had one leaf on it before planting those. So as you can see, that yield loss drops off pretty dramatically if we're not getting germination until crop emergence with some of our plants, or 25% of our plants. You can see how the yield drops off very rapidly, and we get that competition out there in the field. Those less productive and delayed plants also cost more than just yield. When you think about the dollars that we're putting out on each acre in seed, chemicals, and fertilizers, we want to make sure that we're maximizing that return on our investment. And if we're putting seeds out there that aren't pulling their weight, or spending chemicals and fertilizer on those seeds that aren't pulling their weight, we're in the long run wasting money. So again, when you look at it from that standpoint, we want to make sure that we're maximizing our investment and getting every seed up and allowing it the optimal chance at production is the key goal in there. And I'm sure y'all have all heard this before, but that delayed plant acts pretty much like a weed in that it utilizes nutrients and moisture less efficiently than its neighbors. Again, that goes back to how it's robbing light and those types of things, and stealing from the photosynthetic productivity of the surrounding plants. So again, not only are you losing yield in that specific plant, but you're bringing down the plants around it by utilizing that light and nutrition and moisture in that system as well. Next, we're going to cover a little bit some of the other management advantages associated with even crop emergence. Uneven crop emergence typically makes for a little bit harder decision making throughout the year, but one thing that it definitely helps out with is achieving that crop canopy and shading out weeds faster. We all understand the importance of making sure that crop reaches canopy with a weed-free environment, and if we have an uneven stand out there, that's going to make that more difficult. We want to try to maximize the growing degree days in the season. For you guys up north, you're worried about getting that crop out or at least matured before the freeze in the fall. Down here, we're trying to get that crop finished and done before we get to the really hot part of the summer, because it turns out that corn doesn't do too well when it's 105 degrees, as some of y'all might have seen. So anyways, we want to try to maximize the growing degree days in that season. Also, it helps us define application timings in our herbicides, insecticides, fungicides, and then our fertility applications and irrigation scheduling. So definitely making sure that our crop is even is going to help making those decisions. And then finally, it's important for crop maturity and harvest. As we extend that season out, trying to get those delayed plants to finish out, we can really back up our harvest schedule at the end of the season there. Just to illustrate that a little bit better for you, here on the left side, and I know that isn't a no-till field, but it does a good job of illustrating what a uniform stand looks like. As you can see, that crop's getting pretty close to complete canopy there. It looks fairly weed-free versus the crop on the right-hand side. We've got part of the crop that's approaching canopy and other parts of the crop that still are susceptible to invasion or weeds emerging up through that canopy, as you can see on the right-hand side there. So, again, making sure that crop is even across the board. We can time our herbicides correctly and make sure that crop achieves canopy before we get weeds to bust up through the middles. Here I wanted to illustrate kind of what those growing degree days look like. We've all seen daily high and low temperature charts. I just pulled this one from Cedar Rapids, Iowa. But what I want to definitely point out here, if you can see the mouse, is this R1 kind of represents halfway through the season in terms of heat units or growing degree days. So, if we have part of the crop that's, halfway through the crop here, but then some of it's delayed, really what's going to happen is that delayed crop's going to snowball and get farther and farther behind, because heat units start to dwindle as we go later into the season towards harvest. So, you know, again, making sure that that crop is emerging in the correct time back over here at planting, and going through the season in the correct fashion is what we're interested in when we're managing these no-till fields, or any field in general. Defined application timings, like I said earlier, a lot of different chemicals and pests pests actually affect different crop growth stages. And you know, if we have a defined window in that field where we need to be applying herbicides or insecticides, that really makes that management decision easier, and you know, helps us make our decisions a lot more effectively for that crop. So you know, again, having that even stand is going to help with those decisions. Fungicides are the same way. They're often applied based off growth stage and disease pressure. So that window of susceptibility, if we have a delayed crop or a delayed emergence in part of that crop out there, could extend beyond a fungicide's residual window, and could cause problems in that management of that disease. Irrigation and fertilizer, you know, a lot of times we're putting out foliar fertilizer applications. Many times the effectiveness of those greatly depends on when we're putting those out or what growth stage we're putting those out on a crop. And if we have several different growth stages out there in a particular field, we're not as efficiently getting that foliar fungicide or foliar fertilizer on as we could be if that crop was even across the board. And then crop maturity and harvest, y'all are all probably aware of that, especially again up north. You know, that can lead to increased drying costs, high risk of lodging, waiting for some of the field to dry, increased risk of not making maturity before that killing frost, and then you know, we can seriously delay our harvest due to those fewer heat units at the end of the season. Like I said, it gets that snowball effect where we're looking for heat units, but the heat units day by day are dwindling. So now we're going to kind of talk about the causes of seed germination and seedling emergence issues. So what causes our problem here, or what are we trying to solve when we're managing our no-till crops? Soil temperature issues, moisture issues, seed to soil contact issues. All these issues are things that no-tillers or even conventional tillers run into in certain times of the year or certain years, and we'll go through these individually, but these are definitely things that we want to pay attention to when we're no-tilling a crop in, and make sure we're covering all of our bases. This is a chart that I pulled off of an Indiana Extension website, and what I want to illustrate here, if you look at the left side of the graph, that blue line, our bare soil temperatures hovering around 50 degrees there for quite a while. I mean, this graph goes all the way from probably the beginning of April there through about the 20th, 25th of April. You know, we're seeing that temperature hover very close to that 50 degree mark. Well, that yellow line illustrates the days that it's going to take for that corn crop to emerge, and as you can see, I mean, I know a lot of us have gone out and stick our thermometer in the ground, see that temperature get up to 50 degrees and immediately hit the field planting. And I'm not saying that that's a bad idea. I know a lot of us have a lot of acres to get across, but what we're really trying to look for is getting that temperature consistently above 50 degrees, not just right around that 50 degrees. As you can see, the days to emergence dramatically decreases as we get that temperature consistently above 50 degrees. So like I said, that can be a pretty big issue in no-tilling, but it does pay off in the end when you look at how quickly we can get these crops out of the ground. Soil moisture issues, obviously if we have the soil too wet, we're going to get kernel rot, as well as a whole host of other issues in our planting operations, like maybe smearing sidewalls or not closing that seed slice properly. There's just a whole host of problems that come along with that soil being too wet. Obviously, when it's just right, we get germination, but when we're too dry, we get that inert kernel or that kernel that doesn't want to germinate, and it has to wait until it gets moisture in order to swell and then go ahead and germinate. So that can cause a lot of interfield delays, and we see that happen quite a bit out west, where we just simply run out of moisture after that planting operation. Seed to soil contact is definitely important. Obviously, seed to residue contact doesn't guarantee us a germinating seed, neither does seed to clod contact. Both of those can be problems in no-till situations or in high compaction areas. We want to make sure that that seed is real tilthy so that we can maximize that surface area contact with that seed, make sure that that seed's getting adequate moisture and nutrients, and also make sure that there's enough pore space for air for respiration. We don't want to just pack that dirt in around there, but making sure that we get good contact is very important when looking to germinate a seed. I like to say that this is nature's way of ensuring optimal conditions before wasting a viable seed. We've got weed seed banks out there that sometimes last for 20 or 30 years, and you wonder how the heck a weed seed can come and end up in the middle of your field when you don't have a parent weed out there the year before. Well, a lot of that just means that there wasn't the proper conditions for that seed to germinate. So again, making sure that we have those optimal conditions for our planted crop is going to be important to get adequate germination. Soil pest issues, obviously, if you've planted corn or any crop and put any kind of seed treatment on there, you've probably fought against some of these problems: grub worms, wireworms, seed corn maggots, corn rootworms, seedling blight, seed rot. There's a whole host of different things that can happen to a seed via a pest while it's in the ground waiting to germinate and emerge. And the length of time that plant sits underground and isn't providing its own photosynthetic energy just increases that time that it's susceptible to these pests. So we need to make sure that we're doing everything we can to get that plant up and out of the ground and fighting on its own, so to speak, rather than relying on the effects of the seed treatments. I wanted to put this as a diagram in there just so that we're on the same page as looking at these different parts of a corn plant or a young corn plant. If you notice here, we've got the seminal roots, which are really responsible for your nutrient and moisture uptake. Nodal roots are more responsible for your structural integrity or keeping that plant upright. Of course, you got the kernel there with the mesocotyl coming out of it. That's really the umbilical cord for nutrient passage to that young corn plant, at least early on there. So all those different parts of that plant are very necessary and essential when you're looking at the health of a young corn plant. That kernel is the sole source of nutrients until those roots and leaves begin photosynthetic production and carbohydrate production for the plant. So really, once the source of carbohydrates runs out in that kernel, we are on the way down as far as plant health if we don't have any leaves established. Establishment of nodal roots depends on adequate soil moisture and temperature, tilth, like I said, all those other conditions that we talked about previously. If any one of those things isn't adequate, then we get a weak stand of roots and obviously structural issues later on down the road. I just wanted to share with you damage to that kernel or mesocotyl before the nodal root establishment. That emergence through V3 will actually lead to killing or severely stunting that seedling. So again, protecting that plant early on is key to making a healthy, viable plant. And then damage to any of those roots through V6 or V3 through V6 can also stunt that plant or hold it back quite a ways. So making sure that everything is pest-free and healthy, and that's a good, nice environment for that early young corn plant is key to the establishment of that crop. Uneven planting depth, we're all aware that that's a big issue, and that can cause problems with uneven emergence. In a no-till field, it can vary widely due to the trash and residue across the field. Also, it's amazing, but I'm surprised at how often I see carelessness when the planter's set. I see a row unit or two that might be set at a little different planting depth, and that's something that can easily be avoided if you just take the time to make sure that the planter's set correctly. Also, in drier areas, I've seen growers go beyond the recommended planting depths in search of moisture. I know that sometimes that becomes a necessary evil, but if we can try to avoid that, you know, in some of our drier climates, that's definitely something to strive for. And then by contrast, also growers will go shallow in some colder soil situations to try to speed up that emergence, and that can cause corn plants to not get those nodal roots to establish real well. They'll establish close to the surface and not provide a whole lot of support to that plant later on in the growing season. So, excuse me, again, making sure that that planting depth is consistent and correct is going to be important in maintaining an even crop emergence. And then finally, use of starter fertilizers with high potential of plant or seed injury. A lot of times you'll hear the term high salt index thrown around there. You know, basically we want to make sure that we're using products such as Agro-Culture Liquid that are seed safe or plant tissue safe and are capable of not hurting or harming those early young root systems. Here we did a trial at our research farm where we put 4 drops of 9-18-9 next to the seed, as well as 4 drops of our Pro Germinator product 9-24-3 next to the seed, and you can see that the root growth through that band of fertilizer when that in Pro Germinator was much more effective than the root growth using the 9-18-9. There's probably some components of that 9-18-9 that aren't not as plant friendly as our Pro Germinator is, and so you see that in the root growth through that band of fertilizer. Here is a very similar illustration where we use our Pro Germinator product 9-24-3 and Sure-K, which is our potassium product, in a 1x1 band, and then we also used 18-46-0 and 0060 on the other side in a 2x2 band, and you can really see how those roots just have a seriously hard time of penetrating that band of fertilizer on the right there, whereas, you know, root growth into our Pro Germinator and Sure-K is adequate, and those roots are taking advantage of that fertilizer early on there. Some things to avoid when using starter fertilizers. You know, we want to avoid that high salt index. Like I said, that's a term that's thrown around there. That just means the potential for plant or seed injury. Products that contain chlorides or that are highly corrosive, have non-neutral pHs, they contain spent acids or industry waste. All those types of products are going to be very harmful to plant tissue, and probably not something that we want to recommend directly on the seed or in furrow or too close to that seed due to the harmful effects they have on young corn plants. Proper starter fertilizers, you know, we want to look at something that has a balanced nutrition, meaning that it contains multiple different nutrients, N, P, K. Maybe look at some of your micronutrients as well. Plants are kind of like humans in that they like a lot of different types of nutrients and not just one nutrient specifically. So making sure that we match those micronutrients with our macronutrients at specific times of the growing season is important. Having stabilized nutrition at Agro-Culture Liquid Fertilizers, we do some things with our nutrition to extend that release of nutrients over the entire course of the growing season. That helps a lot with reducing the potential of seed and plant injury, but it also gives that plant the ability to take that up later on in its life when it might even need it more. So having those stabilized forms of nutrition in our starter fertilizers is really beneficial and helpful there in furrow. And then obviously you want to try to find a product that has as little a risk of plant injury when applied directly in furrow. And I'll show you some slides here in a little while that prove that in-furrow placement of fertility is the most effective way to use a starter fertilizer. Granted that all the time can't happen, but if we can try to get those nutrients as close to that seed as we possibly can, the benefits of early emergence and early plant vigor is seriously increased by that utility. So finally, we're going to step into how we're going to manage those no-till farming systems to achieve the most effective and uniform emergence out of our crops. So we've understood now the causes of those problems, and now we're going to try to deal with them. Here's kind of the list of things that I'm going to go through here at the end. You know, we'll go through these step by step, but residue management, variety selection, planter considerations, all these things are very important to managing that seedling emergence in no-till crops. Residue management, seriously, this really starts with the combine. We need to make sure that we're uniformly chopping and spreading those stalks behind that are coming through the combine. Try to minimize that windrow of trash or residue that's being thrown out there. That's going to prevent areas of high nitrogen immobilization. If any of you are familiar with the carbon and nitrogen cycles, if we have an area of the field that has quite a bit of carbon in the form of residue, those microbes are going to utilize nitrogen in the soil to metabolize that residue, and therefore it's going to create a nitrogen deficiency zone in your field. So we want to try to prevent that by spreading that trash out as evenly as possible and let those microbes go to work evenly across the field, not just in specific spots. That's, again, going to aid in decomposition of that residue, soil warming, seed depth. When we're planting into it next year, instead of planting into big piles or windrows, we'll have even dispersal of that trash, and it's a lot easier to penetrate and get down into bare soil if we've got that thinner layer. Also, I want to get you guys to understand that we need to cut the crop as high as possible to leave stalks in place. Having higher stalks out there, especially, I saw this a lot in the Oklahoma Panhandle and Texas Panhandle, where we have 50-mile-an-hour winds in the springtime. You can blow that trash around a lot, and in other places, water moves that trash and residue around quite a bit as well. We want to make sure that we can aid in protecting that trash and holding it in areas to where it still maintains that even thin layer rather than big piles of trash throughout the field. And then finally, residue management also it deals with your proper setting and use of row cleaners on your planter. I see guys set these things too deep or too shallow. We want to make sure that we're removing that residue, not removing a whole lot of soil with that process, but making sure that we do get down to that bare soil. It leads to more consistent planter depth and reduces the amount of hairpinning that we get a lot of times in those heavier residue crops while we're planting back into them. Just to illustrate that a little bit, I mean, here on the left is a combine. We've all seen this, obviously, but and it could be the angle of the picture, but I think that this guy could even do a little bit better job of getting that trash out there on the edges. If you look at his header width, we want to see a little bit or a very good even dispersal of that trash and residue coming out of the back of the combine, and so that starts there. And then obviously row cleaners are super important in no-till planters, making sure that we get that residue cleared out of the way so that planter can perform its operation successfully whenever we're going through the field. Variety selection. I want to point out cold germination test scores associated with these varieties. If those are not available on the bag, that's something that you definitely need to talk to your seed rep about. Again, in no-till situations, most of the time we're dealing with germination in cold weather or cold soils, and we definitely want to make sure that the varieties that we're choosing are rated high enough for those conditions. So pay attention to those and not just the warm germination tests. Also look at your emergence and early vigor ratings for these seeds, root and stalk health characteristics. Again, a lot of our no-till situations we're involving our crops and having to come up with through a bunch of trash and those types of things, making sure that we have a healthy root and a healthy stalk is important. Disease and insect resistance, that's important in any field, but especially important in fields where we're looking at continuous corn on corn or continuous cropping, where we have a lot of disease inoculum out there laying on top of the ground that isn't being turned over every year. So, make sure that those ratings are adequate or at least somewhat resistant when you're looking at varieties. And then try to avoid seed lots that have lower than average germ ratings. Again, no-till is a great thing, but it is a little bit more adverse early on with these plants than our conventional tillage, and so we're asking that little bitty plant to do a whole lot early on. And so if we have a lower than average germ rating, that's just one more thing that plant has to overcome to get a uniform stand and uniform population out there in the field. So again, we want to try to plant the best seeds that we possibly can, and all these different ratings will hopefully get you into the right variety and seed selection there. Planter consideration, of course, making sure that your planter is level, both side to side and front to back is important. And make sure, I mean, by doing that, we're making sure that everything involved in that planter operation is working correctly. Our drive wheels are touching the ground appropriately. Our row cleaners are appropriately moving that trash out of the way. Our planter depth is uniform across the entire unit. You know, we also need to inspect our coulters and select those based on the desired level of tillage or residue cutting, the planter weight, how fast we're going to go. Make sure that those row cleaners are removing just the residue but not any soil. I don't like to see a whole lot of trenching going on, which I have before seen guys where they're removing quite a bit of dirt from that row, and then you get a big rain shortly after planting, and next thing you know, you've got a flooded out seed furrow there. So again, making sure that those row cleaners are set correctly and removing the trash but not removing the dirt is important. Seed firmers and press wheels, of course, are important for maximizing that seed to soil contact, and they're even more important in a no-till situation. We want to make sure that we're maximizing that surface area that seed's touching the soil, and those seed firmers and press wheels are going to be important to adjust for that. Double disc openers wear more easily in no-till situations, so make sure that we stay on top of those and maintain them correctly, as that's important for seed slice opening. Cover discs or cover devices, I mean, there's a whole host of different things that guys use to cover that seed up. Obviously, those improve the seed to soil contact and reduce the residue in the row, kind of maintain that residue free zone so that soil can warm up and that crop can take off a lot easier. Planter speed, you know, this has been an issue ever since the dawn of time, how fast guys want to run over the fields, but in these no-till situations, we really want to try to limit that excessive speed going across the field. That planter's going through a lot tougher situations, and so making sure that everything's working according to the plan by reducing that speed is going to be important. I know there's a lot of acres to plant in the springtime, and with no-till, you know, sometimes that planting window can be reduced significantly if there's a lot of moisture events coming, but you know, we want to make sure that we're maintaining that planter speed and not getting careless when we're driving 100 miles an hour across the field. Seed depth, this is something that we need to be checking regularly. Soil type, residue levels, and consequently your depth to moisture changes across fields as you move across them in the planting season. You know, we want to make sure that we're getting off that planter and checking to make sure that our seed is being properly placed in moisture, not too deep, you know, those types of things. You know, again, things change as we go across the field, and we need to be able to adapt to those changes. And then finally, seed population. You know, if we run into a situation where we're planting into heavier residue or something like that, we might need to adjust our seed population to make up for the fact that we're going to lose a few in that planting operation. So, you know, just being aware of the situation and being able to adjust and adapt as we move across the planting or across the field or across the farm is very useful and beneficial in these no-till fields. Seek advice from the soil. You know, planting dates historically have been chosen by the calendar, but now we're you know, in no-till, we're kind of limited to what the field conditions are like. We want to try to avoid those days that are too wet, avoid smearing the sidewalls and leaving seed slices open. You know, we see this quite a bit in some of our no-till fields. We want to make sure that if we are planting in wet conditions that we're utilizing those seed firmers and making sure that seed slice is getting closed, trying to use some of the implements on our planter to agitate that soil to improve the seed to soil contact, like your closing devices and things like that. And then also realize that, you know, if you've got a field that's historically wet with no-till, drainage systems such as tiling can really help to add some of those suitable days to your planting season and allow you to plant a lot more within that planting window, and really that helps out a farmer tremendously when he's looking to plant a whole lot of acres in a small amount of time. Scouting and treating fields for pests. No-till residue provides a home for a lot of insects, diseases, rodents, and small weeds. So those conditions may, in fact, minimize the effectiveness of some of our pesticides, herbicides, those types of things, and we need to keep a watchful eye out for some of that. Also, timing of our herbicide treatments is crucial for efficiency and effectiveness in no-till situations, because we have limited rescue options. You know, we're not planning on putting a cultivator in these fields and taking care of the weed escapes and stuff like that. So we need to make sure that our herbicide selections and our herbicide timings are really going to do the trick in knocking out those weeds and keeping a clean field throughout the season. And then again, to cover again the disease ratings on our varieties, you know, we need to pay close attention to that. And then also, if we're in that continuous cropping system like continuous corn, we probably just need to go ahead and plan on a fungicide application due to the fact that the disease, or so much disease inoculum, is present out there. Managing for compaction is another key thing to look out for in no-till situations. Again, we're not putting a whole lot of iron in the ground in these fields, so we need to control our traffic pattern, minimize the number of trips with heavy loads. GPS, using that for our applications, making sure that we're running over the same tire tracks and staying in those row middles. Check our tire inflation on all of our equipment to ensure that those are properly inflated and not doing something harmful to our field as we're going across there. This picture on the right is a picture actually pulled off of a Louisiana website, but it's a compaction issue that they're having in corn here, and what you're seeing is actually potassium deficiency. Many times compaction will rear its ugly head in the form of a nutrient deficiency or a drought. It'll almost look drouthy. Because the pore space in that soil is completely bound up, and the roots can't penetrate it as well, and so therefore they're not getting adequate moisture and nutrition to that plant. So again, that's just to kind of illustrate what compaction will do for you if you're not careful about where you're driving and in what conditions you're driving. So and then obviously you know, ways to manage that would be, you know, utilizing tillage or cover crops to maintain those lower soil bulk densities. We want to make sure that we get in there and you know, plant some of these over the winter time to try to help improve our field conditions and prepare our field for the spring. Soil testing, it's important obviously in conventional farming, and it's even that much more important in no-till systems. You know, we want to make sure that we're adequately providing our plants with the proper nutrition. Keep in mind, nutrient stratification is pretty common in no-till systems, since we're not incorporating a lot of our amendments and fertilizers as efficiently as we would be in conventional tills. So you know, making sure that we're using the proper depth of soil sampling and things like that will give us a better idea of what kind of nutrients we need to be applying and how much we really do have out there. Depth of sample is one of the key errors when sending in a soil sample. If you're not careful and consistent on that depth, it can really throw off what kind of results you get back from the lab. So keep that in mind and make sure that you maintain that consistent depth and let the lab know what you're how you're testing that soil. And then again, I'm going to talk about you know, a little bit more on planter time or starter fertilizers. Obviously, being a agronomist for Agro-Culture Liquid, I feel like this is one of the things that's really essential for maximizing the performance of your crop in a no-till situation. Cold soils equals slow root growth and slow release of nutrients from organic matter. So, you know, if we're putting that seed in the ground in a situation where it's got very few nutrients to work with, if we can give it some nutrients early on to get it up and out of the ground, we're really going to see the benefits of that come yield time. And in a lot of our research, we've noticed that we can have earlier maturity and lower grain moisture at harvest when we apply these nutrients early on in the season. And we feel like that's due to the faster germination and early growth of that plant. We're taking advantage again of those growing degree days more efficiently and everything else. Again, in-furrow placement of those products, if possible, is most advantageous for a fast response, because we're getting that nutrient right there in the seed zone, and that seed can start taking advantage of it from day one. Here's a illustration of that in the form of one of our trials this last year on our research farm. We went out there with 4 gallons of our Pro Germinator product, 7 gallons of Sure-K, and 2 quarts of Micro 500. And we did 3 different application types. On the top bar, you can see we did a spring broadcast application of these products, and then in the middle bar is a banded 2x2 application with the planter, and then the lower bar is the planter in-furrow application. And as you can see, the in-furrow application pretty handily beat the other two. Obviously, the banding of those nutrients close is important versus the spring broadcast, but even getting it closer in that in-furrow tube is going to be very essential in getting that plant off to a healthy start. This test also illustrates that in some degree, but what I also want to point out is the purity or the quality of the product. Here we put out 5 gallons of Pro Germinator in furrow, which ended up winning the plot at 223. We did 5 gallons of Pro Germinator in a 2x2, and as you can see, that distance away from the seed reduced the yield somewhat because it wasn't able to take advantage of it there immediately. A lot of times we don't see that big of a difference, but in this particular case we did. And then moving on down the list, we put some other products, including 1034O in furrow at 5 gallons per acre. Again, I think that the quality of the products here is, 1034O has quite a few characteristics that don't lend themselves to being very friendly to young plants, and so you probably aren't seeing the benefit of the phosphate in that 1034O as much as you would in the Pro Germinator, especially in an in-furrow situation. But then when we backed that 1034 out and added quite a bit more in a 2x2, we saw a little bit of an increase there. But still, the Pro Germinator, the high-quality product in furrow, is what we're really looking for to maximize that early season vigor and emergence out of those crops. And then nitrogen application considerations. This doesn't have a whole lot to do with our initial stand or our uniform stand in a no-till environment, but one thing I do want y'all to consider is, broadcast urea and UAN applications over the top of residue and no-till crops is really opening up your possibility of volatilization, especially if you don't have any rainfall that occurs relatively quickly after that application. We really recommend, and as you'll see here in a minute on one of the next slides, trying to inject that nitrogen with a coulter or knife, or if not injecting it, we'd like to see a surface band or a dribble. Again, banding that product versus broadcasting it over the entire field is really going to help out the efficiency and reduce some of that volatility that we see in those broadcast applications. And here's the illustration of that. We have the top bar there is a broadcast application, and we did this both with high energy N and 28 and our nitrogen product enhancer, our nitrogen enhancer. And in this trial, you can see we did high energy N broadcast, and then the next bar down would be high energy N in a split application in a 2x2, and then side dress, and then high energy N and a side dress alone. And then the same thing with 28% down in there at the bottom. And as you can see, there's definitely a yield advantage to banding that nitrogen closer to the seed and concentrating it versus broadcasting it out across the entire width of the row. And then finally here, again, I want to encourage you guys to look to others for advice. Obviously the No-Till Farmer magazine website and webinars. I hope you got some benefit out of listening to this today. Seek out other ag professionals. Our staff here at Agro-Culture Liquid Fertilizers, our sales staff, agronomy staff, and research staff. I know I travel all over the country as well as a lot of my colleagues. We've, if it's possible, we've probably seen it in some form, and we have a lot of ideas and advice that can hopefully get you through some of the tougher situations when you're looking at no-tilling your crops. Also, equipment dealers are a good resource. They know what their equipment is capable of doing, and being able to match that with your operation. So seek out their advice, and then of course chemical and seed reps know what their products can do in these no-till situations. extension agents and publications, they're always good sources of advice. I got a lot of material for this presentation off of some of those websites, but they're always they're out and they see a lot of this. They do a lot of research on how to improve some of these methods, and so they're always good resources. And then other growers, as I travel around, there's always one or two growers, it seems like, in every community that's dabbling in no-till or has already gone to no-till, and those guys can be excellent resources when it comes to giving people advice on how to navigate the challenges of this no-till. And so I encourage you guys to seek out as much advice as you possibly can. In conclusion here, I just wanted to list some of my sources again for this presentation. A couple of these here are extension websites, mainly from Purdue, and then of course our website's always available at www.agroliquid.com. We have research reports spanning the last decade or more on there, and as well as resources where you can find different people to talk to, phone numbers, addresses, those types of things. So we encourage you to look at that and take a look at our products, when you're making a decision on fertility in these no-till crops. And that's about all I've got. Daryl, if there's any questions, let me know.
You bet, Reid. Thank you very much. And yeah, we'll go over a few questions here, and some of this might retrace a little bit of the ground that you went over this morning, but maybe you'll be able to give a little more detail into some of these questions as well. Here's one. Can you go over a little bit about how soil pH might affect seed germination, and perhaps where you want to, whether there's a point where you get too low in pH and how that might affect your germination? Do you have any information on that?
Yeah, well, of course, we always strive for that 6.5 to 7 pH. I mean, that's typically where most living things and most crops do well in, and a lot of that has to do with the nutrient availability in the soil at those pHs. If you look across a nutrient availability chart, just about every nutrient is available in its maximum amount in those pH ranges, and if you deviate either high or low from there, you start getting into nutrient deficiency situations. And so, yes, where is that line? I mean, with different crops it's different, and obviously that depends on what nutrients they're looking for, what's important to those individual crops. But making sure that we're trying to get the most optimum nutrition and optimum conditions, the microbial makeup of the soil, all that is very dependent on the pH, and if we stray too far from that neutral to slightly acidic range, we can start running into problems either way of that side of the spectrum. So. Okay.
What about, we talked maybe about corn, but what about with soybeans when it comes to germination and emergence? Do you see any differences between corn and soybeans, or the things you talked about today pretty much apply to both, or maybe there's just a few differences you can talk about?
Well, there is some differences. I will say soybeans have the capability of making up for its neighbor's lack of yield or delayed emergence, what have you. That crop is able to compensate quite a bit more for that than a crop like corn that has one reproductive site and that's it. So. Yes, soybeans, and also soybeans do a lot better job of emerging in these no-till situations than corn does. I mean, it seems like it's not quite as sensitive as corn is when it comes to needing the most optimal conditions. So, like I said, the fact that it has the ability to compensate, for its lack of support with its neighbors definitely is a difference, and then the fact that it does tolerate some of those harsher conditions in no-till early on makes it quite a bit different than corn. So.
Okay. Always a big question is talking about with your in-furrow pop-up fertilizers, the type of rates and really what is safe, and you kind of touched on this a little bit too, but safety is always a big issue. So if you could maybe address that again, the type of rates you're probably looking at with an in-furrow type of program.
Well, rate of in-furrow application fertilizers is going to depend greatly on a number of different points. One of those being the type of crop. I mean, corn seed can seem to handle quite a bit more. It's got a thick, waxy kind of kernel that can handle and stave off some of the effects of those higher salt qualities of fertilizers. Whereas soybeans is a little bit more sensitive. Soybeans, cotton in my area, cotton is a very sensitive crop to some of those higher salt index products. Also, your soil type or soil texture, I guess. If you're dealing with a sandier type soil, there isn't as much buffering capacity or nutrient holding capacity, whatever you want to call that, around that seed. And so, really, if you're in a sandier situation, you might want to be a little bit more careful than a guy that's dealing with a little heavier soil. And then, obviously, moisture, the more adequate moisture you have, the more you have the capability to dilute some of those salts out, and the higher rates you can run in those situations without the risk of injury, just simply due to the fact that you're diluting that product out with the moisture available in the soil.
Okay.
So it's tough to say. I mean, it's hard to give a specific number. Obviously each product varies and each field varies by soil type and each crop varies by sensitivity. So, just do some research, understand what soil type you have and what product you're dealing with, and generally you can get a fairly accurate answer out of that.
Okay. And obviously, in no-till situations, we're dealing typically with a lot of trash and a lot of residue. What, in your opinion, is the best way to maybe avoid, tie-up issues that you might have if you're streaming on fertilizers? Have you done a little work into that? What type of system you might work with in trying to avoid those tie-up issues when you're streaming it on?
Well, like I said, banding is going to be your best bet in avoiding tie-up or really any adverse things happening to your fertilizer. Whether that be a surface band or if you're actually injecting that fertilizer somewhat, even in a 2-inch deep or 4-inch deep side dress type of application, yes. Managing that residue is important, and it's even more important in a no-till situation because that can take a significant amount of that fertilizer away. And we've found that, like I said, banding, whether that be surface banding or injecting, is going to be the key to staving that off, I guess.
Okay. Reid, to what degree have you had a chance to look into cover crops and how they might impact germination and in your final stands? And I mean, do you have any kind of recommendations for guys? Do things change if they're working with cover crops at all?
Well, honestly, I don't have a whole lot of experience in cover crops, but I have seen some of the research on them. Anything that's going to be available to increase the tilth of your soil, hold on to some of those nutrients over the winter time, those types of things is obviously going to improve your situation when you're planting and looking to emerge those crops. There's so many different options out there. It's hard to nail down one specific one that would be the best or whatever. I mean, it just depends on your situation. But I do highly recommend the use of cover crops in many situations, especially in no-till. That can just really improve the seed bed and everything else out there in the field as you move across your farm.
Okay. Have you had a chance to work with any or many of the market aftermarket fertilizer attachments that you could use perhaps on a John Deere planter? Do you any recommendations there, or things you've seen with any of those attachments that might do a better job with plant applications of fertilizer?
Well, I mean, without specifically naming products, I mean, like I said, in furrow placement, basically that totally tubular system is probably what I would consider the best option if you're looking for an in-furrow placement. We also use Y-knot splitters on some of our more sensitive crops to try to get that fertilizer off to the side, onto the sidewalls rather than directly on the seed, in some of those more sensitive crops. Obviously 2x2 is 2x2. Truthfully, I tell guys this, and I know that the research shows that you do see a little bit of a yield drag not going in furrow, but we have a lot of guys that do surface banding of our phosphate and potassium products, in a 0x2 or a 0x0 out the back of the planter, and it's a cheap application or a cheap way to rig up your planter, and it seems to be close to as effective versus broadcasting or something like that. So you don't have to get super complicated with it, especially if you want to try to avoid some of the complications that come along with 2x2 or in-furrow applications with nozzles plugging up and those types of things. You can just go out the back of the planter too for simplicity's sake.
Okay. We hear a lot about, and this maybe gets us a little beyond just plant applications, but just in general about matching the nutrient application to your crop's growth curve. And what do you see as far as perhaps the different application timings that really seem to work well with, say, the growth of corn? Are there certain things that you recommend or certain timings of split applications perhaps?
Well, yes. With our product line, as specifically talking about Agro-Culture Liquid, we do a lot within our products to try to extend that release over the growth curve of that crop. And a lot of times we will try to do the best we can in matching that product with the application that we're looking at doing, to try to get that release to occur over the same release as the crop. Side dress applications of nitrogen. Our high energy N product is a 60 to 90 day, or we claim 60 to 90 day release. And so, we're trying to extend that release of nitrogen out farther into the season than your standard or conventional 32 or 28 products. So, again, making sure that product not only does the job that you're intending it to do at that particular application, but making sure that its benefits extend on out into the season to take care of that crop, especially in reproductive mode and those types of things is important. Now, as you get into foliar applications, those are the types of applications that you want to see the product go out there, do its job immediately, and that be kind of the end of it. Obviously, extended release type products in a foliar system are not as recommended as they are at the beginning of the season. So.
Okay. Got a question just came in here about are there any type of slow wetting liquid fertilizers that might help to improve a soybean seed's wettability if they tend to be very dry?
Oh goodness. I guess I'm not 100% familiar with a whole lot of those types of products, so I wouldn't be, I guess, qualified to make a remark on that. So
no, that's fair enough.
Okay, sorry.
Don't want to answer something that if you haven't had a lot of experience with, that's for sure.
Absolutely.
No.
Absolutely.
How about anything on the side with biologicals? We see a lot of products coming out now that are termed biologicals that can help promote germination. Have you had much time to work with some of those and see how they work?
Yes, we're actually working on some of those products, and we have some of those products available as well. For a lot of years there was kind of a stigma that went along with some of those products, and there is a definite science behind them. A lot of times it's trying to match the microbes or the bugs in the jug, I guess, with the soil type or the crop and those types of things. What might work in one area might get out-competed by the natural bacteria or natural microbes in another area. So I think that there's still a lot of work to be done in that area, and I think there's a lot of potential in that area of the industry. but yeah, I mean, I think a lot of people are looking into it, and I think there's a lot of merit behind some of these products. You know, I've noticed on our farm we've done quite a bit of work with them and seen good results across the country with some of our newer products that contain those microbial components. And I've heard some outstanding results from some other companies as well. So, like I said, I think there's some science behind it. Do I think it's perfected yet? No. I think there's some more work to be done there. But I think that as research and development improves and moves along in some of these companies, we'll see a lot more of those products come to the forefront and have more consistent yield growths.
Okay, let's take one final question here, and we're going to switch gears a little bit into strip till and see if you might be able to help here as far as any research you've done with applying fertilizer in strip till applications. And obviously, you guys worked with liquid products, but anything you guys have done in that arena with strip till and what you've seen for results?
Yes, we actually have a Orthman strip till unit at our farm that we've done some work with Orthman directly on their farm and our farm some cooperative work, and we've seen great results by applying nutrients down in those strips. You know, depending on what area you're in and you know, what kind of rainfall you're looking at, what kind of freezing weather you know you're going to be dealing with over the winter, whether you're applying that in the fall. We've done a lot of different work on that to make sure that we're getting the maximum effectiveness out of those applications in the strip till. I mean, there's things to be considered when you're applying a nutrient out there several months in advance ahead of a crop or whatever. So yes, we've done a lot of that work. A lot of that's available online at our website, agroliquid.com, or I believe it's even on the Orthman website. I haven't been on their website in quite a while, but we've done a lot of cooperative work with them to see at what levels those nutrients need to be, you know, how things work, you know, in that system as you progress through the fall and winter and then on into the spring at planting time. So.
All right. Thank you very much, Reid. Thanks for answering all those questions. And before we conclude, just a heads up that when you log off today, there'll just be a short questionnaire we're going to ask you to complete. Very simple, small number of questions, and that really helps us determine the value of today's webinar and with planning for future ones. Second, we will be making available via email to you a replay of today's webinar in the event you'd like to go back and review the entire presentation or parts of it. You'll also find that replay will get put up on our No-Till Farmer website shortly, and there's also an archive section there where you can go back and listen to other webinars recently completed. And we got through most of the questions today, but there's a few that we didn't. We're going to pass those on to Reid to answer, and we can post those with the webinar replay as soon as they are available as well. So I want to thank you, Reid, again for leading this discussion. Again, Reid Abbott from Agro-Culture Liquid Fertilizers, and do want to thank Agriculture as well for sponsoring today's webinar. And I want to note the work of our producer, Cole Vandermouse, again, for keeping us on track with the webinar today. Hope you guys are enjoying the warmer springtime temperatures we've had this week, and it's getting you in the mood for planting season. So thanks again for joining us, and so long until next time.
Thank you, Daryl.